So let's consider this example. We evaluate the limit of sine x as x approaches 2 pi over 3. So since 2 pi over 3 is an element of the domain of sine x, then we can substitute right away. Okay? So this is now equal to sine of 2 pi over 3, or that is equal now to square root of 3 over 2. Okay, caution lang dito guys, no? 2 pi over 3 is in radians. So in degrees, that is 2 times 180 over 3, or that is equal now to 120 degrees. So sa calculator ninyo, kung ito yung gagamitin ninyo, make sure na naka-rad kayo, yung R na symbol. Okay? Kung naka-D kayo, ibig sabihin ito yung kanyang binabasa. So we evaluate the limit of x cosine x as x approaches pi. So since pi is an element of the domain of cosine x, so pwede natin siyang substitute. So that is now equal to pi, okay, times cosine of pi. Okay, so we now have pi, cosine of pi is negative 1. Okay, cosine 90 degrees yan. Therefore, we have negative pi. Minsan, yung argument ng ating trigonometric function is hindi lang kasing simple ng x. Okay? For example, in this case, we are evaluating the limit of the secant of 1 over x as x approaches infinity. Okay? Observe that the limit of 1 over x as x approaches infinity is equal to 0. Pag-aralan natin yan sa limits at infinity. Okay? And 0 is an element of the domain of secant x. Therefore, pwede nating ilagay lang si 0 doon sa 1 over x. Diba? Doon sa theorem 2 natin. Sabi ng theorem 2 natin, kung meron tayong, parang ganito yan. G of x is equal to 1 over x. Tapos, f of x equals secant x. Therefore, f of g of x equals secant of 1 over x. So, parang ganon. Okay, so ang sinasabi niya, theorem 2 natin, kung meron daw tayong limit ng g of x natin na equal to k, at yung k na yon ay element ng domain ng secant x natin, therefore, pwede nating ilipat yung k na yon doon sa ating function. Therefore, we now have secant of 0. Okay, this is now equal to 1. So let's evaluate the limit of sine of the tangent of pi times x squared minus 1 as x approaches square root of 2. So ito, meron ulit tayong dalawang function. Meron tayong g of x dito, tapos yung ating f of x. Observe that the limit of tan pi x squared minus 1 as x approaches square root of 2 is just equal to 0. Tama? Square root of 2 squared minus 1. So 1 times pi. Tan pi is 0. And 0 is element siya ng domain ng sin x natin. Okay? So by theorem 2, pwede nating ilagay lang yung 0 doon sa g of x natin. So we now have sine of 0, or that is equal to 0. Minsan, yung mga limits involving trigonometric functions may result to infinite limits. So this type of limits result to vertical asymptotes. So let's take a look at this example. The limit of cotangent x as x approaches 0 from the right. So we know that 0 is not an element of the domain of cotangent x. Okay? Makikita natin yan sa graph natin. However, pwede natin tong gawing limit of, kasi alam natin cotangent x is equal to cosine x over sine x, right? So we have the limit of cosine x over sine x as x approaches 0 from the right, which is equal to, ano ba yung limit ng cosine x natin? 1. Okay? Over, ano yung limit ng sine x natin as x approaches 0 from the right? That is 0 positive. And this is now equal to positive infinity. We evaluate the limit of the negative of sine cube x all over 1 plus the square root of 2 sine x. So pag titignan natin yung graph niya, the graph of f of x near x equals negative pi over 4, meron siyang vertical asymptote at x equals negative pi over 4. Thus, we say that the limit of the function as x approaches negative pi over 4 is equal to positive infinity. Ngayon, i-confirm natin kung yung limit ba na yon is true, analytically. Okay, so we multiply here the conjugate of this. So we have 1 minus the square root of 2 sine x over 1 minus the square root of 2 sine x. So we now have the limit of the negative of sine cube x times 1 minus the square root of 2 sine x all over 1 minus 2 sine squared x as x approaches negative pi over 4. By direct substitution, this is now equal to the negative of 2 square root of 2 over 8 over, eto naman magiging 1 minus 2 times sine squared of 45 degrees, 0 from the left. Okay, pwede yung i-check yan sa inyong calculators. So therefore, this is now equal to positive infinity. So how about the limit of tan x as x approaches pi over 2 from the right? So we know that tan x is equal to sine x over cos x. So we can rewrite this as the limit of sine x over cos x as x approaches pi over 2 from the right. Note that pi over 2 is equal to 90 degrees. So sine 90 degrees is 1 over cosine x cosine 90 degrees is equal to 0 from the left. Okay? So pwede yung i-check yan. Therefore, the answer is negative infinity. Let's evaluate the limit of cosine x over x as x approaches 0 from the left. So by direct substitution, that is equal to 1 over, since x approaches 0 from the left, so by substitution that is 0 from the left. So the answer is negative infinity.